case you want to put in case
Go
you
ahead.
want to the image on the left side and a paragraph on the right side, and you want a background color like a box or something that highlights the image and the wordings. How do you do that?
Right. So that's a bit more prolonged process for that. Perhaps we can come back to it once we're done with today's session. Is that okay? I mean, you just have to add in a lot of stuff here and there
Yeah.
to get that done. But it's possible, right? Let me just tell you that it is possible. You can do that. The process is a little long than just adding an image, right? So we will try our best to come back to that. And any other questions? All right. In that case, I will begin. I'm going to keep it really simple. All right. I won't take a lot of your time because, as I understand it, today is supposed to be your project discussions. Can you let me know if my screen's visible? Can one of you just unmute and
Yes,
let
sir.
me know?
Yes.
All right. Awesome. Thank you. So right,
Yes.
today the first thing that okay, thank you. So today the first thing that we'll be doing is something called tables. And most of you have already seen how tables look. You've been drawing tables your entire life, if it's your experiments or whatever it is. What we'll do now is we will try to make those exact same tables in LaTeX. All right, and I will hide this left side thing because that's not required. And I'll zoom in a little bit here. All right, so instead of the first section being introduction, I'm going to call it tables. Let's compile it. Oh, one shortcut on overlay for you guys is Control plus Enter compiles your document, right? So you don't always have to go click on recompile. It says Control plus Enter is your shortcut. So if you don't see me clicking here and there, that's because I'm pressing Control and Enter. Okay, so tables is quite easy on LaTeX, and all you have to do is begin an environment, right? So it's a backslash begin. Probably because I've zoomed in too much that the thing is not coming. Either way, begin. It's something called tabular. Okay, there is something called table, but we'll stick with tabular here. All right, and once you do that, Overleaf provides you with the entire syntax of how a tabular is supposed to be. Right, so I will just get rid of all of this, and I'll tell you what all of that means. Right? So we have a begin and end tabular, but we also need to specify how many columns are we supposed to have. Right, so for that, I will, at the end of begin tabular, I will open a new set of brackets, and I'm going to say C space C, right? C for column, which means my particular table here is going to have two columns, right? And we begin our entries. So you don't specify the number of rows. All you have to do is to specify the number of columns, and you're done with that. You can have an infinite number of rows if you wanted to, right? Okay, now here I'm gonna, so everything that if you're familiar with Excel sheets, all of those boxes are called cells. So I'm gonna be using that name here. I'm gonna call this cell 1, right? And I'm gonna call this cell 2, and I'm gonna call this cell 3. That's, I'll assume that it's my first row. And in my second row, I'm gonna have cell 4, cell 5, and cell 6. Okay. Actually, no, let me just get rid of these, right? Because we just said two columns. So I have two columns here and two rows. Let's just compile it and see what we get out of it. Well, it clearly does not look like a table to us, right? I mean, that's not how I wanted it to be. So the thing that we are supposed to do here is a few symbols here and there, right? I'm just going to put these symbols first, and then I'll let you know what they are. Right. Now let's compile it and see if we get our table. We do, right? It looks like a table without the lines and stuff, but it does look like an arrangement of cells. Now, what exactly have I done here? Right? This ampersand symbol, this and symbol, specifies or distinguishes between your first column and the second column. Right, so everything before the and symbol or the ampersand symbol is going to be your first column, which means cell 1 and cell 4 are elements of the first column, and everything after the symbol are going to be the second column. Cell 2 and cell 5. Now, if I was to do this, right, if I was to put another cell here, right, do you think it'll work out? Can one of you just probably unmute and let me know if this will work?
There will be an error
And why will there be an error?
because we specified there will be two columns.
Exactly, right? So let's just compile that and see what we get. Right, so you see automatically cell 3 has been pushed down, right? And it says extra alignment tab has been changed. Whereas we defined only 2 columns, but I'm saying that there's 3 columns, so that's not allowed, right? So that's something you have to be careful about. Now the double backslash here, excuse me, signifies the end of your particular row. Right? The double backslash says that the particular row, the first row is ended here, and now I'm supposed to move on to the second row. Okay, so if I wanted to add another row here, I have 2 rows. If I was to add another third row, I would have this cell 6 in the column, in the first column, and cell 7 in the second column. We will recompile this, and now it's fine, right? 1 4 6 2 5 7. It looks like a table. But now let's say I want it in the center, right? So I'm going to leave this table as it is, and I'm going to start a new one. Begin, tabular, and it gives me with everything, but I'm going to get rid of those. Right. Now, again, I'm going to keep only 2 columns for our purposes, and we'll change the elements. Cell A and cell B, and cell C and cell B. Right. I will recompile this, and we see that this is sort of right below that table with some indentation, right? So to get rid of the indentation, I will just put no indent. And but then the whole purpose of me doing this is because I want my table to be in the center. And so for that, what you use is begin center. All right. And I'm just gonna cut this entire tabular and put it here. Now I can get rid of the no indent because it's gonna be in the center. And we will recompile this, and there we go. Right. So with the begin and end center, there have to be begin. There has to be a set of begin and end. You can center your table. Now there are of course other ways you can go about it, but I will leave that to you as an exercise. Okay. Now let's come to putting lines here. Right. I want my tables to have lines and stuff. For that, on your keyboard, wherever you have the backslash symbol, if you were to press shift and the backslash, you get a straight line. Right? If you're not familiar with it, it's shift and the backslash key. It may, perhaps in some keyboards it might be different. I'm not entirely sure, but you should have a straight line with the shift key. Right? Now, once that is done, let's recompile our document and see how we have it. Now we see that a center line has been added to our document, to our table. Right? So that straight line signifies that there's a center line, a division line between the 2 columns. Now let's say I want lines everywhere, right? On the left, the center, and the right. We've already done the center part, so I've added the same symbol on the left and the right, and we'll recompile this. There we go. Right, so we have lines at the left, center, and the right. But I also want above and below and in between the rows. So for that, since that is a horizontal line, we call it H line. So my first H line should come before my first row. That's why it's right above cell A. And after I finish my first row, I need another H line, right, to differentiate between the 2 rows. And after my final row, I need another H line to close the table. We'll recompile this. There seems to be some error. Uh, okay. Or perhaps this. Right. So the error was that I had to end my row here, right? Otherwise, H line would have just continued after cell D. So if you want to put an H line, make sure that you end the row right there and put your H line. And now we see that we have a proper closed and lined tabular column right there. Right. Now the rest of it is quite simple. This is the absolute basic to your tables, and anything further that you require. So if let's say I want 2 lines on the left, a single line in the center, and 2 lines on the right, I'll just put 2 straight lines over there, and you see that I've gotten 2 lines there, right? And so on and so forth. I will leave the rest up to you to explore, right? But this is the absolute basics that you would probably if you've already started writing your papers or anything. Anything more, and you can reach out to us. But I feel this is more than enough for you to start off with tables. Right. Now that we're equipped with this, what we will try to do is a small task, which is to reproduce this particular expression. Right. It's totally fine if you don't know what this is, but for the ones who are familiar, this is called the Levi-Civita symbol. Sort of arises when you're doing outer products or vector products and so on. Right. So what we will try to do is we will try to reproduce this exact same thing through using our codes. Right. So we see what let's sort of analyze this. Right. So on the left hand side we have an epsilon, that's called an epsilon, the Greek letter epsilon, and in the subscript we have an I, J, and K. So there's that, and then there's an equal to sign, and then we have a big curly bracket. Right. We have a large curly bracket which has 3 rows in it. So there itself, you should be getting an idea that here is something, I mean, this is one place where we can use tables, right? But instead of using tabular like we just did, we're going to use something else, a more general stuff called arrays. And I will show that to you in a moment, right? So in the first column, I have 1, -1, and 0. And it looks like in the second column, there's this IJK, and else, and so on. Right, so we will try to reproduce something like this, not the exact same thing. I mean, I'll try to reduce all of these numbers and stuff, but we want to reproduce this exact same thing, right? So let's start with that. I'm going to call a new section now, and I'll call this the Levi-Civita symbol, just that. I'll just add a simple line, the Levi-Civita symbol is defined as, right, whatever it is, right? And I want this to be a numbered equation, so I'm going to say begin equation. All right, scroll down. Yeah. Now on the left hand side we had an epsilon subscript IJK, right? So epsilon subscript IJK. Now I hope you're already familiar with subscripts and superscripts, which means you should be knowing why I put the IJK inside curly brackets. It's to make sure that all 3 IJ and K are in the subscript, because if I was not putting them inside the curly brackets, only one of them would be in the subscript and the other would not be, right? So let's actually take a look at that, shall we? Epsilon subscript I, right? AK, right? This is how you would probably look at it, and I'll put an equal to sign, and we'll recompile this. Now you see, I might have to probably zoom in a bit more, but I hope it's clear. Only I has gone into the into subscript, whereas J and K haven't. And the other difference that you notice is the epsilon that we have over here is not the same as the epsilon that we have in the image that I'm showing it to you right now. Right. So what we do for that, it's a special kind of an epsilon. We will call this the var epsilon, which stands for variable epsilon. Right. So that gives us that fancy epsilon that we saw in the image. And since I want all I, J, and K to be in the subscript, I'll put them in curly brackets, I, J, and K equals. Now let's see if that is fine. Perfect. Right. Now here's where the thing comes. So on the first thing that you encounter after the equal to sign is a large curly bracket. So for that we use left, and since curly bracket we want this to be a part of text, I will put a backslash and curly bracket. That means it's going to be a big curly bracket and not just some command. Now anything that I'm accompanying with left has to be ended with a right, but I don't want a curly bracket on the right side, so I'll just put a dot. It doesn't really make a difference, right? It's just to make sure that you've closed your left side. And now in between this is where our code goes, so I will press enter twice. Now we're supposed to put that table with 2 columns and 3 rows. So for that, what I will be doing is I will begin an array. Okay, overleaf gives me a prompt, begin array, and it says CNC, which means it's going to have 2 columns, and it's already given me the entire syntax for what I'm supposed to do. So I will just proceed with this since we're already familiar with how to type our tables and stuff. The first one was +1, right? I'll put that as a +1, and let's go like this, right? Let's go row wise. So we have +1, and then we have ijk 1 2 3 2 3 1 3 1 2, but they're just called even permutations, right? So I'll just type, I'll just put a text because we are still inside math mode since we started an equation, right? So I'm going to say text even permutations, right? Now I need another row with a -1, and for this it's going to be odd permutations, and I need another row because there was a 0 as well. So 0 and to differentiate between the columns, text otherwise, right? And the array ends here at line 41, and you end the right because you started a big curly bracket here, right? So let's compile this and see if we get what we desire. And there we go. Let me zoom out a little bit. There we go. Right, so we have +1, -1, 0, even permutations, odd permutations, and otherwise. Okay, so yeah, that's pretty much it for these kind of equations. If in case you require them, I'll just show you. I'll quickly show you another example called the Dirac delta. The Dirac delta function is defined as. Now, I won't be reading this out to you, but I hope you can see what I'm typing. And I make a lot of typos. Please do excuse me for that. So what I'll do is I will add a little bit of space in between. What quad does is it gives me a space equivalent to, or it gives me a gap equivalent to 4 spaces, right? It's almost the same as pressing space 4 times roughly, or 1 tab space. That should be a better approximation. Right? If you're already familiar with the Dirac delta function, this is how it looks like. And you see there's some space that has been provided between 1 and I equals j and 0 I not equal to j and so on. Is the Dirac function correct though? Yeah, it's correct. Right, so that is a brief about that. And this brings us to our next topic, matrices. But before I proceed, are there any questions? Let me stop for a while for questions. There seems to be something in the chat box. Okay. So Sagar has told about that. Any questions? You can unmute or raise your hands while I have a sip of water.
What is slash quad for?
Sorry? I didn't catch that. Okay, so \quad, like I said, it adds a little bit of space between your stuff, right? It's like instead of so there's 2 ways you can add some space between your things, right? I think Sagar showed you this yesterday. Okay. I will recompile this. Right, so that's one way of adding space. Now, what happens if I don't put that? Let's first see a difference of that. Right, you see I and j, I mean the first or how should I put this? The second element of the first column, right? No, the second element of the first row and the second element of the second row are not properly aligned, right? That's another problem with we see right here with the Levi-Civita symbol. The otherwise is actually in sort of center aligned, right? So in sort of to avoid that, we can add a little space here, right? So I use quad, which adds roughly a tab space, right? Because if you were to just put tab, it doesn't give that space, right? If this quad wasn't there, right? And if I just press tab, it doesn't really make a difference, right? I'll press space 4 times. 1, 2, 3, 4. Right there in my code, there seems to be a lot of space between 0 and the sentence, but when I compile it, it doesn't really make a difference, right? So in order for it to make a difference, I prefer putting quad. That's my method of doing it. Sagar uses the backslash and semicolon. There's also another way you can do it, which isn't that doesn't give a lot of space, but you can put a backslash comma as well. This comes in handy when you're doing integrals and stuff, but it sort of serves the purpose, right? You just have to put a lot of them to properly align. But to avoid all of that, it's like a fixed unit of spaces, so white cap. Right, so the vegetable vendors have also come in now. So you see, that's what I'm talking about. It sort of gives you equal amounts of spaces between your cells. So if I was to do this here as well, I'll just put that semicolon that Sagar has been doing. And let's see if what this does to our expression. Not much difference, even though it is actually shifted a little bit. It doesn't make a huge difference because it's quite a small one. Right? So instead, now I'll put quad for all of them and compile. You see there's more gap now between the +1 and the other one. Right? So it just depends on you. If you want spaces between them, if you don't want spaces between them, that's totally left up to you. Right? So I will remove quad here, and you will again see a difference. You see they're closer now, right? So it's just that, it's just left up to you. Any other questions? Because if this is understood well enough, then matrices is just a piece of cake. It's just some types of matrices that you will have to remember. Right, let me just have a sip of water, and if there's any questions, I'll be happy to answer them. Excuse me. Right, so if there's no further questions, let's quickly proceed to matrices, and then you can all take a break. I'll just add a little bit of gap here, and we will begin with our new section, which is all about matrices. Let's in fact start this on a new page so that we have a fresh start. All right, perfect. Right, so we have matrices. Now again, your matrices are sort of a little special cases of your tables and arrays, and they look fancy, right? I mean, they're not your regular tabular columns that we've been doing so far. They don't look like the cell A, cell B, cell D, cell C, and so on. Neither do they look like cell 1, cell 2, cell 4, and so on, right? It's sort of a between thing. It's sort of in between, right? So in order to accommodate for that fact, the fact that these are mathematical structures, we will import a package. We will use a package, which we've already used before. Use package AMS math. I hope it's clear enough. Please do let me know if it's too small for you to read or something. Right. So we will use this package called AMS math, and we will come down here to matrices. And there are several types, right? So what we will do is I will tell you the types of matrices that are most commonly used, and I will leave it up to you to figure out if there are more types of matrices that we encounter in different types of papers, right? Okay, so I will write a simple line here. A plain matrix is just an arrangement of elements. We call them elements. Right now, all of these are mathematical structures, which means you have to deal with them in math mode. Right? So I will put them under double dollar sign. If you're not already familiar with this, double dollar sign make sure that your equation is not numbered and also in the center of the page. Okay, so I will add some space here. Now, in order to type a matrix, we again begin an environment. Since we're doing a plain matrix for now, it's just matrix and end matrix, right? Anything that begins has to end. And the rest of it is quite simple, right? It's exactly how we put these cells here. So the first row I will say will have numbers 1 and 2 and 3. That's the first row. And I will break this row, and the second row will have alphabets A and B and C. The only reason I'm giving spaces here is just to make sure that it's readable, it's legible to understand. That space is not necessarily important. The major difference that we see here for matrix and regular tabular columns is that we don't have to specify the number of columns. Right? We don't have to specify anything. We just say begin a matrix, and then you give as many columns and as many rows as you want. It doesn't really make a difference. Right? So let's compile this and see what we get. I have to scroll down to the matrices section, and there we go. It is just a plain arrangement of numbers. There's nothing special about it. Right? It doesn't even look like a matrix or the ones that you are familiar with from your 12th standard, 11th standard. Right? So now we will come to those. A matrix with round brackets, right, is called in Italian parenthesis matrix, or in bold P matrix. And how do you get this is, again, I will work in math mode, begin P matrix, right, and end P matrix. Okay, so I will put that in a new line, and everything else again remains the same. So I'll just copy paste this part 1, 2, 3, and ABC. Right? And we will recompile this. And we see now there's a set of round brackets that have been added to our matrix, and now this looks more of a matrix that we're familiar with from our maths textbooks and so on. Right? Any questions so far? I think the spelling of this is wrong. It's probably parenthesis. I'm not sure. Or, yeah, it's fine. Okay. So similarly, you can also have a matrix with square brackets, right? With square brackets, and that is called box matrix, right? Or P matrix. So the whole process again is the same. Begin B matrix this time, and the rest of it is really the same: 1, 2, 3, ABC. And there is a slight difference in that you have a square bracket right there. Right now, let's say you wanted a curly bracket matrix, right? A matrix with curly brackets is given as, I should get to math mode. Again, let me scroll down a little bit. Right now, there's a slight difference here, so I'll probably put this here. Is given as, or is used with. This is quite I don't know, tricky to remember. Capital B matrix, right? Where the capital B stands for braces. That's what we call left brace and right brace. So begin B matrix, and the rest of it really remains the same. It's just the types of brackets that you're changing for your particular matrix, and there we go. We have those curly bracket matrices. Now, if you're familiar with determinants, right, a determinant is also a matrix with vertical lines on both sides instead of brackets. And this is used with B matrix for I don't know. I prefer calling it vertical matrix, but you're free to remember it however you want. Right? It's usually V matrix, and the procedure again is the same. Again, V matrix and copy paste 1, 2, 3 A, B, C. This is not possible because the determinant has to be a square matrix. So I will add another row. It's just the mathematician in me isn't quite satisfied. So that's good. Now you can find the determinant of this. Now there are other instances in more higher level algebra where you find something called the norm. You don't have to worry about it. They're just determinants with two lines instead of a single line that I've showed here. So we'll just call that double-lined determinants, right? Because that's what they look like. Double-lined determinants are used with capital V matrix, right? That's the slight difference between that, and this again remains the same. Again, capital V matrix, and I'll copy paste the same thing and add another row, compile. There we go. Right, we have double lines now. So you don't have to manually add two lines for your particular matrix. LaTeX does that for you with capital V matrix. And so on. Right. So there are other types of matrices like the ones where you have what do you call it? The Dirac notation, if you're familiar with, they sort of have these angled lines in them. Right. So there are matrices like that. There are matrices where one of them is an angled line and the other one is a straight line, and so on and so forth. Right? I will leave that as an exercise to you to sort of explore what other kinds of matrices can you make with the symbols that you already are familiar with. And Sagar will also be sending you a list of symbols in a PDF format after this particular session. Right, and with that, we are at an end to today's topics. Any questions? I will be happy to answer them. And yeah, thank you for listening to my ranting for so long. I'll stop sharing for now. If you have any questions, then I can reshare my screen. All right. Wow. No questions. That's nice. Either everything is crystal clear or nothing is. I don't know. I can probably can some of you unmute and let me know if you understood stuff. Okay, Josiah says it's clear. Thank you.
A bit.
A bit, okay. You still have some issues anywhere that I can help you out with, or do you want to learn that for yourself by yourself?
I think by myself will be good.
Perfect, no problem at all. But if you do need some help, you can reach out to us, me, Sagar, anyone. Anirudh says it's clear. Thank you very much. All right then, Sagar, I think you can take over. I'm done with my session. You can send them that list of symbols, the PDF on the group, on the Telegram group later on.
Yeah, Vikram. So thank you for the session.
Right.
Okay, guys. Coming to the next part.
Hey,
So-
one sec.
Yeah.
Anushka has a question. What is the purpose of text IT? So there are different types of texts that you can have in your document. If you want bold, then it's text BF. BF stands for bold-faced. Text IT is for italics, right? The IT is for italics and so on. Now for underline, it's slightly different. So it's not text UL, but there are, of course, different commands for that. So text IT that I used gives me italic text. Text BF that I use gives me bold text. And there are other, you can also get a typewriter type of a font by using text TT and others that you can explore. Right? Let me not spoil it for you. Anushka, I hope that clears your question.
Yes.
Also, awesome. Also, thank you, Astha, Prerna, and Sanket. Awesome. Sagar, sorry to interrupt. You can proceed.
Okay, I think someone was about to ask it out. Is it?
Yeah, I had a doubt. How do you write chemical structures and bonds?
Oh, okay. So for those again, you will require special packages that deal with chemistry of it, right? Those are specialized functions of LaTeX, right? I mean, those are specific uses. So for those, you will have to import, or like I said, like I use the package AMS Math. You will have to uh, import or use different types of packages for your orbital diagrams or chemical formulae, or if you're familiar with Feynman diagrams, then there's a specific package for Feynman diagrams. There's a specific package for circuits and so on and so forth, right? So, but you can write a basic formulae, right? If you want to write H2O, that's quite simple. You just write H and then subscript 2 and then O. So basic chemical formulae and basic chemical equations are easy to write. But if you are looking for complex molecular structures with double bonds and triple bonds and so on, those will require special packages. Ansi, I hope that clears your question.
No, actually, I wanted to know how to draw the molecular structure of like acyclic and cyclic compounds.
Yeah, so that's exactly what I'm saying, right? You need packages for that, right? Those more complicated packages which have their own set of commands, which you will have to learn separately. Those will not be covered these basics here,
Yeah, okay.
right? Yeah. Anirudh, I see your hands up. Any question?
Yes, actually, I wanted to ask that is there any similar package for drawing a plotting a graph, or do we have to plot it using Excel and then put it here?
Yes. No. There are packages for plotting as well, and I think if time permits, we might be covering basic drawing in LaTeX and basic graphing as well. So what we will show you probably is simple plotting like sine curve or exponential curve and so on. But that will give you an idea, so you can go ahead and plot and stuff. I hope that answers your question.
Yes, thank you.
Awesome. So for that, we'll be using something called a text package, which will be covered in probably after a few sessions. Not entirely sure of the timetable, but yeah, we will be doing basic diagrams in LaTeX, like probably draw your axes, x, y axes, and some simple diagram. And we will also try to cover basic thing using another package called PGF Plus. And we'll cover basic graphing, like plotting out sine curve, exponentials, logarithm. Maybe if you guys are okay with it, and depending on the response when we do that, we can also have a look at 3D plotting. You can plot 3D stuff on LaTeX as well. It's a bit computationally expensive, as in your computer uses more of graphics and RAM and stuff, but that's still possible. So we will try to cover that depending on your responses and your progress. Right. So if that answers everyone's questions, anyone else? All right, Sagar, I think now you can proceed.
Yeah, bro. Okay, guys. So coming to the mini project, is everyone clear about your projects and your buddy group, or you have any doubts?
Yeah, we are clear.
So everybody know your buddy and also your problem statement, right? So I thought there'll be doubts, and I kept like 20 minutes for this session. Luckily, like Vikrant covered it till 6:45, so that from 6:50 you can have your project discussion with your buddy in Discord. So there are 9 teams as far as I know. So, and there are 9 voice channels in Discord server now. So go to any voice channel with your buddy and then have a discussion with your buddy regarding the project. Okay. Okay, and we can be telling if you need any help with topics like quantum mechanics or quantum field theory or particle physics, he can help you. Okay, sorry, my voice is cracking a lot. Okay, guys, so we can continue in Discord. Okay.